Okay, everyone. Am I mic'd? Can you hear me on the mic? No? Okay, so I can talk my normal teacher volume. Okay, everybody. Hi there. All right, I will be using the .cam again today for the little intros and things like that, so I can record the video. I think I posted it. Let's find out. Share the screen. Hold on. Share screen. All right, here we are. So let's take a look at our calendar first. Today is May 7th. We'll be doing section 5.2 today. Tomorrow we'll do 5.3. You have it's going to be a shorter Thursday because you just have a wrap up. It's called a mock midterm. It's not a midterm. It shouldn't be called a mock midterm. It should just be called a wrap up. It's a wrap up. It's due the following Monday like usual. And Friday we have 5.4. You have your regular weekly homeworks due. Quizzes are graded, but grades I don't believe have been released yet, but we'll do that soon. And your next quiz is not next week, it's in 2 weeks. So you get a week off from quizzes. Anybody have questions about the calendar? All right. So I think, let me check. Did I put, turn this volume down. That's better. Hopefully this can still hear me though. Let's see. So I think it's probably in module week 5. Yep. So I put a May 3rd lecture video up there. I'm going to do this with these videos. I'll probably just do this from now on. It can be helpful for review. And like I said, I don't do the whole class. I just do when I'm up here talking. So I'll do that again today. I'll probably drop it underneath the Tuesday place. So let's stop share. What's going to make more sense? I'm thinking this is going to make more sense. Okay. You all see that okay? All right. So we did 5.1 last week. That's about quadratic functions and the different forms of a quadratic function. Just as a brief review. We've got 3 different forms. I like to call them y-intercept form, x-intercept form, max-min form. Another Caspian said another way you could think about vertex form is transformation form. Because in vertex form, you can start with your basic x squared, and then you transform it by shifting it right 3, stretching it vertically and flipping it by -2, and adding 32. So you could think about vertex form as transformation form, moving it around, stretching it out, and flipping it. All right. With that information, hopefully you all have this in here. Standard form tells you the y-intercept. Vertex form tells you the coordinates of the vertex. Factored form tells you the x-intercepts. There are, of course, quadratic equations or quadratic functions that don't have x-intercepts. Maybe this one like that. So that one you can't write in factored form, bless you, using real numbers, which is what we use in this class. Complex numbers, yeah, but we don't do that in this class. A is the leading coefficient. If a is 0, the quadratic will open up. If a is less than 0, the quadratic will open down. So you can check your notes and make sure that we're all in agreement on this piece here. Okay, we talked about converting from standard form to vertex form. You have to keep that leading coefficient. That's the easiest thing to forget. The x-coordinate of the vertex is minus b over 2a. The y-coordinate, you just plug it in, and it kicks out the y-coordinate. Then you write it in this form, and the other thing you want to make sure you don't forget is you don't want to forget that squared term, because you still have to square it in order for it to be quadratic. And then we found the vertex a couple different times in a couple different ways. And now we're on to section 5.2. We're on page 121. Don't worry about this. You can if you want to, but I think it's a little confusing. A little more information all in one place than you really need. I think if you just work through things step by step, you'll be fine. So 5.2 is polynomial functions. There's very little that's new in this section. We're just asking you to do some more with it. We've already talked about multiplicities and how you zoom in to the x-axis when you want to know about multiplicities. We've already talked about end behavior and how you look at the arrows to determine whether it's an even or an odd and whether the leading coefficient is positive or negative. So you get some practice with that. If you turn over to page 123, question 7, I just want to write the hint. You can factor x squared out of this polynomial because it's in each of those terms. If you're wondering, how am I supposed to solve k of x equals 0 with a 4th degree polynomial? Generally, we don't have the tools for that. But if we're lucky enough that we can factor out an x squared, then it is possible. All right. Questions 8, 9, and 10. These are the meaty questions. You will have a question on your next quiz like this, but I want to do an example of it. Example question 8 on page 124. We start with a graph. And let's say it looks something like that. Let's say that point is minus 4. This point is positive 1. And that point is positive 5. With this information, we should be able to come up with a very good guess for what this function actually is. First of all, is this an even or an odd degree polynomial? How do we determine that? Look at the end behavior. Exactly. Is it going the same direction? So it must be an even. Yep. So it's an even degree. Okay, that's good to know. Is the leading coefficient positive or negative? Positive, because it goes up in both directions. So we can actually determine quite a lot about this. Do we know the x-intercepts? Yeah, they are. Yep, we just look at the graph. So could we figure out the factors of this polynomial? Yeah, definitely. How about the multiplicities on the factors? Can we figure those out? Yeah, as long as we zoom in and we say, what does this function look like close to minus 4? What does it look like close to minus 4? Quadratic. So what's the power on that factor? 2. Yeah. How about close to 1? We're trying to make it look like a waterfall. So it's a odd, and it's at least 3, and let's keep it simple and stick with 3. Could be 5, could be 7. We're going to keep it simple. And then here, close to 5, it looks linear. So what's the power? 1. Yep. So we should be able to write all that information down and then check it against the graph. I should have an x plus 4 with a power of 2. I should have an x minus 1 with a power of 3. And I should have an x minus 5 with a power of 1. And it should open up. So I should have some leading coefficient that is positive. And I want you in this class to actually write the letter A and then write A is positive. Because if it was open down, we still need a leading coefficient. And we would write A is negative. And the reason I want you to do this is very simple. This is how I wrote the quiz question. I want you to get used to it. So when you see that as an option, you're not like, what does this mean? Right? You'll have done it a couple times. Okay, so we need to make sure that the degree is even. So what's the degree of this polynomial? Is it the largest power on a factor or the largest power when multiplied out? Which one? Largest power when multiplied out. If you want to go for the largest power, it needs to be in standard form. We don't have it in standard form. So how do we get the degree when it's in factored form? What's going to be a power on this term when we multiply it out? And the power on this term? And the power on that term? And when you multiply x squared times x cubed times x, you get x to the 6th. You add up the powers, i.e. add powers on the terms. So the degree is 6. Why do we know the degree can't be 3 from the graph? Because the shape would be different, right? The shape would have arrows going other ways. So you can check your logic against the graph. That's another thing I want you to be thinking about is, okay, I wrote a formula down. Wait a minute. This looks like a degree 5 because 2 plus 3 is 5 and it can't be 5. So what did I do wrong? Forgot to add the degree from the x minus 5 term, right? Okay. So we're almost there, but we don't know what A is. We had 3 pieces of information from the graph. This x-intercept, this x-intercept, this x-intercept, which gives us 3 pieces of information in our formula, but we're missing a piece of information. So we need one more piece of information. So what if I told you the y-intercept is 0, I have to pick big number. It's still not going to work out very nicely, but I don't care. How about 0, 40? This is an additional piece of information, and we can use it to find our missing piece of information from the formula, because we know if I put f of 0 in, I'm going to get 40 out, which is a times 0 plus 4 squared times 0 minus 1 cubed times 0 minus 5. Oh, I did good. Does that make sense? Now we just say, okay, that's a times 16 times negative 1 times negative 5. What's 16 times negative 1 times negative 5? Positive 80. 80a. So 40 is 80a, so a equals 1/2. That's kind of the additional thing we're asking you to do in this section is once you get a possible formula based on graphs, multiplicities, and end behavior, use a point, which is an additional piece of information, to get that additional missing piece of information. So my final formula is f of x equals 1/2 times x plus 4 squared times x minus 1 cubed times x minus 5. All right, and with that, I will invite you all to get started. I'll stop recording. Unless, wait, are there any questions first? It's good if there are, yeah. I will zoom out, yeah, in just a minute here. Actually, I'll do it now so whoever's watching the video can see as well. There we go. All right. Yes, question. Good question. Do I want you to make up a y-intercept? No. You will say something like you are given the point 3, 1, or you are given the point -4, -10. I just made it up that time because I needed to finish out the question. And you can use you can use a lot of different points. There are some that won't give you trouble. If you tried to use this -4, that's not going to help. But as long as you have one additional point, that gives you that one additional piece of information, which lets you figure out that last missing piece. The crazy thing about polynomials, and we're not doing this in this class, not only could I use the roots, I could use any 4 points on the graph and I could figure out exactly what that formula is. If I had a 100-degree polynomial, how many points would I need? I think it's like 101 at most, or 100 at most, something like that. Okay, go ahead and get started.